Hi my friends, in this video I'm going to calculate this limit. It is the limit when x approaches 0 of this fraction. Let us say that I have an exponential exponent sinus of x minus cosinus of x over x. As you can see, I will get, it is easy to understand, I think, here it will come a to 0, it is 1, okay, minus cosinus of 0, it is 1, okay, minus 1, over 0. So I will have something like this, it is 0 over 0. So I must, it is an intermination, and I must apply to some limits, that they are called the notable limits. And I must manipulate, let us say like this, this expression to get the value of this limit. And the two limits that I must apply, I'm going to write them over here. It is the first one, it is the limit when x approaches 0, okay, the exponential, which exponent it is x minus 1 over x, and this limit, put this in your head, it is equals to 1. And also the limit of when x approaches 0 of sinus of x over x, it is equals 1. So I must, let us say, I must manipulate, okay, this expression in a way to have these two limits. So how can I do to make the things easy? Let us to develop this expression in this way. Okay, if I want something like this, it is easy, I think, to understand that it is the same as to have the limit when x approaches 0 of, let's put in numerator the exponential a to sinus of x minus 1, because I want a 1 over here, you see, but I'm changing the expression and I cannot do that. So I'm going to put this inside parentheses. So now I'm going to add 1 minus cosinus of x. Let's go to put this also inside parentheses, okay? It is more nicer, and I think you understand better what I want to mean with this, okay? So now I'm going to apply to the distributive property, and I will get the limit, of course, the limit when x approaches 0 of, and as you know, the limit of a sum, it is the sum of the limits. So I will get exponent sine of x minus 1 over x, okay, that's good. Let's say so far so good, plus limit, okay, when x approaches 0 of 1 minus cosinus of x over x, okay? But if you substitute x by 0, it will, this first expression, it will turns something like 0 over 0, okay, and here again 0 over 0. So I'm going to manipulate this also again, the first one and the second one, in this way. So having this expression, it is the same as to have the limit, okay, when x approaches 0, okay, fraction, I will have in numerator exponent sinus of x minus 1, and I'm going to put here sinus, you see, sinus of x but I cannot change the expression, so I must put here another factor. Let us say I'm going to put here sinus of x, you see, because this one will cut with this one. I am not changing anymore the expression, and I put here x. And now for this one I'm going to make a very nice, and I think it is a very pretty, let us say like this, manipulation. I'm going to multiply both terms of this fraction by this 1 minus cosinus of x. I'm going to multiply by 1 plus cosinus of x. Also, I'll do the same at the denominator, so I'll get x times, okay, 1 plus cosinus of x. That's okay. That's okay. That's okay. So for this limit over here, I'm over here, this one over here, and because of the limit of a product, it is the product of the limits. I'll get the limit, okay, when x approaches 0 of exponential sinus of x minus 1 over sinus of x times the limit, okay, when x approaches 0 of sinus of x over x plus, and now I'm going to make here the calculations. You see, here it is, I think it is quite simple to understand that I will get 1 minus cosinus squared of x. But applying to the fundamental formula of the trigonometry, as I know that sinus square of x plus cosinus square of x, it equals 1. This over here it will come equals to sinus square of x. Okay, that's good. So I'm going to put here, of course, because this product, it is equals to 1 minus cosinus square of x, it is equals sinus square of x over x times 1 plus cosinus of x. Okay. And now to calculate this limit, I'm going to change the variable. Let us make this another variable. Let us say that sinus of x, you see, it's equals t. And when x approaches 0, it is quite simple to understand that t approaches 0, because sinus of 0, it is 0. So I can easily transform this first limit in something like this. It is the limit, okay, when t approaches 0, okay, I have exponent t minus 1 over t times, and now I have the other limit, when x approaches 0 of sinus of x over x plus the limit when x approaches 0. And now I'm going to decompose, or in other words, I'm going to make some manipulations in this expression, and I will get sinus of x, okay, over x times sinus of x over 1 plus cosinus of x. Very simple to understand, I think. And now it is almost done, because as this limit and this limit, they are equals, you see, they are equals to 1. I have no more problems, because this one it is 1, okay, times this one it is 1, okay, times 1, plus this one it is 1, okay, times, let's just see what the value of this limit. When x approaches 0, sinus of 0, it is 0 over 1 plus cosinus of 0, but cosinus of 0, it is 1. So I get 1 plus 1, it is 2, so I get 0 over 2, and 0 over 2, it is 0. So I will get over here 1 times 0. So, but as 1 times 0, it's equals 0, I will get, of course, 1. And the value of this limit that I had put over here, it is, as you could see, it's equals 1. So this is my video for now. I hope so much that you did enjoy it, and I will come later. Bye bye, my friends. See you soon.